One of the great things about using RFC 1918 private address space is that we don't have to register with any authority. We can just use them in our networks. However, it introduces a challenge if we want to route packets from our users on the inside out to the internet, which uses public routable addresses. So to bridge that gap, we're going to use some type of network address translation to facilitate it. So let's consider our network topology for our lab environment. We'll have this puffy cloud here in the middle, the 67.83.0 network. We'll have that represent the internet. And then everything over here on the left-hand side, we'll say that's our corporate office, maybe the headquarters site. And everything over here on the right of firewall 2 is our branch office. And we'll also presume for this network topology that we've got some default routes in place, including firewall 1 has a default route pointing out to the internet, so does firewall 2. And the PCs at headquarters are using firewall 1 as a default gateway, and the devices at the branch office are using firewall 2 as a default gateway. So for a PC over here on the branch office to get out to the internet, it would be firewall 2's responsibility to be trained and then to do network address translation on behalf of PC2 before those packets were sent out to the internet. And that's referred to as source network address translation. So if PC2 is at the IP address of 10.3.0.100, as its packet gets sent out to the internet, the network address translation is going to do source NAT. That refers to swapping out or replacing the source IP address on the initial translation as that packet is being forwarded from the inside network going to the internet. So the question might arise, if we're going to swap out the source IP address of PC2, what would we use? And the answer is we're going to use something that's routable on the internet. So if PC2 is going out to a server, we'd swap out the source IP address with some global routable address. And then if the system or server responds back, this firewall 2, acting as a NAT device, would need to untranslate the address that it used for the initial translation, put it back in place, and then continue to forward the packet back to 10.3.0.100. And it's because the initial translation was the source address, and that's why it's referred to as source NAT. So regarding the addresses that we could use for the initial source translation, one option is just translate everybody into the same IP address that firewall 2 is using on this outside interface, E0. And in our topology, that's 67.83.0.112. And it's possible to translate thousands of source IP addresses into a single IP address. And behind the scenes, this network address translation device is going to start tracking and manipulating port numbers to keep track of all the individual sessions. So when those replies all come back to the same IP address, the session tables will all be unique, and the port numbers will all be tracked as part of that, so that the firewall can take the replies that come back, untranslate those, and then forward them back to the correct parties on the inside. And that's typically what is referred to as PAT, port address translation, because it's tracking the port information as well. So we can think of PAT as a subset of NAT. And in a checkpoint environment, this is also referred to as hide NAT, because we're actively hiding or translating those source IP addresses before the packets are being sent out to the internet. Now, in contrast to the initial translation being done on the source IP address, another option is destination NAT, and that refers to the firewall doing the initial translation regarding the destination address. Case in point, if we have a server up on our DMZ, or a server on the inside, because the concept would work the same. Maybe that server, and let's go ahead and put them over here, a little more room. So let's say we have a server, and that server's address is .100 on the 192.168.1 network. Well, that server's IP address is not reachable over the internet. So what we could do is a static translation that maps that address of 192.168.1.100 over to a globally routable IP address that's been assigned to us. So for this example, let's imagine that we're going to map that over to the address of 67.83.0.100. So we would refer to this as a static translation, a one-to-one translation, meaning one inside address to one globally routable address. And now when a user on the internet, let's go ahead and take Lois as a typical internet user, when she goes to a website, she's usually typing in a name, and then in the background, DNS resolves that to an IP address. If the resolution is to this IP address of 67.83.0.100, and the internet routes that over to firewall 1, with destination NAT, if we have this rule in place, the firewall, acting as a NAT device, will translate the destination from 67.83.0.100 and translate that destination to 192.168.1.100 and then continue to forward the packet over to that server. So that's the initial translation that's being done by the firewall for destination NAT because we're translating the destination address for that static mapping. And then for that reply back from the server back to Lois, the firewall would swap out the 192.168.1.100 and replace it with the source address of 67.83.0.100 and forward it back to Lois. So Lois and the computer she's using doesn't really know or care about our static mapping. All she knows is that she went out to a resource, she got a response, and she's happy. In this nugget, we've taken a look at the concepts of source and destination NAT in a checkpoint environment. I hope this has been informative for you, and I'd like to thank you for viewing.